Hi ladies, this video is about quadratic regression using your graphing calculator. So in this first example, example 4, we're going to use our calculator and it says that the table shows the height of a baseball hit with X representing the time in seconds and Y representing the baseball's height. So here you can see these are our X values and the height are our Y values. So we're going to use our graphing calculator to find the best fitting model for the data. So this isn't going to be a perfect quadratic model. It's going to be a model that best fits the data. So the first thing we want to do is go into our calculator and anything that's in your y equals, clear that out. So if you have anything in y equals for any of these, clear out that data. And then the second thing we want to do is make sure our plot is on. So again, in your calculator, we're going to go to second, and right above the y equals is that stat plot. So go to the stat plot. And we're going to turn the stat plot on. So my first one is on. You can see that by entering and then either choosing on or off. But we want it on, so make sure on is selected. And then next we're going to set our window. We want to set a window that's appropriate for our data. So if you look at our x values, the smallest x value we have is 0. And the largest x value we have is 8. I usually like to go a little bit above the largest x value just so that I can have a little bit on the side of my window. So my x minimum I'm going to set to 0. My x maximum I'm going to set to 10. You don't want it too far, too much bigger, but a little bit bigger is fine. And the scale of my graph is 1, and that's fine. Now I'm going to set my y window. So right here, the smallest y value I see is 3, and the largest I see is 40. So I for sure want my y value to at least go up to 40 and down to at least 3. And I'm going to give a little bit of variance on either side. So my y minimum is 0, my y maximum is 50. The next thing I'm going to do is enter my data into the lists. So I'm going to quit out of this, and I'm going to go in my list. So I'm going to find list in the stat section, and I'm going to edit. And here you can see these lists. Now, if you already have data in your lists, so this is if you already have data in your list, you can go to stat, and number 4 on my calculator is clear list. So if I have data already in list 1 or list 2, I can clear list and select second, and right above my 1 is list 1, and enter. It says done. So that means my list is clear. You could do the same for any other lists that you have. So I'm going to enter my data into the list. I'm going to enter my X data into list 1 and my Y data into list 2. So my X is 0, 2, 4, 6, and 8. And my Y data is 3, 28, 40, 37, 26. So now I've got my data already in my lists. Now I want to graph that data. So I'm going to graph. My stat plot is on. I'm going to graph that. If you look at this model, it kind of looks like a parabola. It's not perfect because we don't really have enough data to fill in all of the other spaces, but just looking at this, I could connect these points and make it look like a parabola. So I'm going to find a line that best fits this quadratic model, and I'm going to use this using quadratic regression. So notice the shape of the parabola, it opens down, so I expect my A value to be negative. So using our quadratic regression in our calculator, we go to stat, and then in this calc section, we see this quadratic regression. That's number 5, quadratic regression. So we're going to calculate the quadratic regression for these two lists. So our X value is list 1, our Y value is list 2, And then we're going to store this regression in our y equals. So in store regression, go to vars, which is the variables, and we want the y variables, and we want it as a function. So we'll put it in function y1, and then we'll calculate that. So now it gives us our a, our b, and our c values that we'll use to write our quadratic function in standard form. And then when we graph this, because we stored it in our y equals, we can see the actual quadratic model of the lists, the regression lists that we put in. So if we were to graph this model where A is negative 1.55, B is 15.18, and C is 3.37 into the form y equals ax squared plus bx plus c, this parabola is what we get. And if you look at this, it goes through most of our points almost perfectly, and so that really is the model that best fits. So please see me with any questions and try the next example on your own, and shortly I'll post the solution. Thanks, and have a nice long weekend.